Okay, so now let's discuss cube roots. Cube roots, alright. So when we're trying to find cube roots, if we take a look at a number line, on a number line, well, we know there's a zero in here. The cube root of zero we know is zero. Now, all the other cube roots that are integers, we can look at those. For instance, we know that the cube root of 1 is 1. 1 times 1 times 1 is 1. We know that the next number that's an integer that we know the cube root of is 8. The cube root of 8 is 2. 2 times 2 times 2 is 8. And the next one that we know, the cube root of 27 is 3. And we know that the cube root of, let's see, what's the next one? 64 is 4. 4 times 4 times 4 is 64. And let me see, the cube root of 125, that's 5, right? And we know a few more, like, I won't put them on the number line. The cube root of what, 3, 6, oh, 216 is 6. Cube root of 343 is 7. Yeah, we can go on with that list. And then we also know about the negative ones, like for instance, negative cube root of 1 is negative 1. Negative cube root of 8 is negative 2, and so forth and so on. In this case, also, the cube root of negative 8, of negative 1 is the same number as the negative cube root of 1, and same down here. The cube root of negative 8 is also equal to negative 2. No imaginary numbers here. Not for cube roots. Not for cube roots. But you know what kind of numbers we do have? We do have some irrational numbers inside here. We still have rational numbers that are fractional, for instance. We still have like a rational number like between 0 and 1. We still have the rational number cube root of 8 over 27, which is just 2/3. That's rational. But we also are going to have some irrational numbers in here. Some irrational numbers. For instance, between the cube root of 1 and the cube root of 8, you have a bunch. You have the cube root of 2. That's irrational. There's no whole number, no integer, whose cube root is the cube root of 2. Who are the cube root of 2, I should say. There's no number, no whole number or a rational number that you can multiply by itself 3 times and get 2. And then of course the cube root of 3 is here, the cube root of 4. These are all irrational. Cube root of 5, cube root of 6, cube root of 7. Those are all irrational numbers. And of course the cube root of 8 is 2. The cube root of 8 is 2. Cube root of 9 is irrational. Cube root of 10, all of those are irrational. And I forgot the cube on one of these radicands. Did I forget it anymore? No. One of those radicals, I forgot the cube. All right. So let's take a look at a specific irrational number and see if we can't break it down into a rational factor times an irrational factor. So let me see. There's the cube root of 64 is 4. And we have that the cube root of 27 is 3. What about the cube root of 54? What about the cube root of 54? Well, let's see, the cube root of 54. Let's see if we can break that down, the cube root of 54. Well, there's many ways we can factor 54. One of them is the cube root of 27 times the cube root of 2, right? We could do the cube root of, let me see, 18 times the cube root of 3, right? We could do the cube root of, let's see, 9 times cube root of 6. Is this all of them? Let's see, 2 goes in, 3 goes in, 4 doesn't, 5 doesn't, 6 goes, 7. Does 8 go into that? No, 8 doesn't go into that number. So I think that's all of the factorizations. The only interesting one here that has any rational factors at all is this one right here. That one has a rational factor. Neither the cube root of 18 nor the cube root of 3 is rational. Neither the cube root of 9 nor the cube root of 6 are rational. The only one of those that's rational is the cube root of 27, because I know the cube root of 27 to be 3. So this is 3 cube roots of 2. 3 cube roots of 2. Let's take a look at one more here. Alright. Let's look at the cube root, let's say, of, let's say the cube root of 40. The cube root of 40. Alright, well, we can break this one up. There's many ways of breaking up 40 also. There's the cube root of 20 times the cube root of 2. There's the cube root of 3 doesn't go in, but 4 does. 10 times the cube root of 4. There's the cube root of 5 doesn't go in. Oh, 5 doesn't go in. The cube root of 8 times the cube root of 5. But 6 or 7 don't go in, and there's 8 on the list already. So these are all the factorizations. Are any of those factors rational? Do I know any of those cube roots to be rational numbers? The cube root of 8 I know. The cube root of 8 I know, and I know it's the rational number 2. So the cube root of 8 is 2, so the answer is 2 cube roots of 5. And maybe one more example. Let's try the cube root of 250. The cube root of 250. Well, the more adept you become at this, the more you'll be able to see the factors you need, because the numbers you're looking for are these factors here. You don't have to go through a whole list. You're looking for the cube root of 8 as a factor, or the cube root of 27, or the cube root of 125, or the cube root of the next one, 216, or the cube root of 3. You're looking for one of these numbers. I mean, as you see, the numbers are getting large. But these are the cube roots here. And this is why we're looking for these numbers. That's why we're looking for these numbers. And the only number I see on that list that's a factor of 250 is this one right here. So I see I can factor 250 into the cube root of 125 times the cube root of 2. And the more adept you become at this, the more you realize you're only looking for these factors right here when you're dealing with cube roots. Yeah, you're only looking for those factors right there. So let's see. 125 times 2, we said, right? Cube root of 125 is a rational number 5, and the cube root of 2 is irrational. So there's the final answer.